Good evening. My name is Tony Mactudis, and this is the presentation of my final project for Android Fundamentals. Basically, my idea for this project was to create a first prototype of a remote display for one of our ultrasound machines at work. So when you want to test a particular part with ultrasound, basically what you do is you hit it with a very short, intense burst of acoustic energy, and then you stop and listen for the echoes. You can see kind of a representative scanner over here on the right. This is offered by another company. So I wanted to create something similar, but in my case I wanted to add the ability to monitor several channels at one time. So you can see the effect I was going for here. There's a screenshot of the screen here displaying 4 traces at one time. So the ultrasound data is being read in from a static file by a separate thread. As our professor has said many times, you want to move as much of the processing as possible outside of the UI thread. So the data is being read in by this thread and formatted for display. It then takes this data and posts it to a separate queue for each plot. And within the UI thread, I have a separate fragment monitoring an individual queue, and so when the data shows up in that queue, it is then displayed to the screen. This makes it very modular, very easy to add an additional plot. So here you can see the app actually running. It's reading in ultrasound data from a file, and these traces look similar, and they are similar, but they're actually a separate trace for each channel. Here the screen is being updated at a rate of about 10 Hertz. So elements used from the class. Obviously the graphics and the user interface was something I had to pick up outside the class from books and from the internet, but the internals all came from the class. So I have a single thread, as I said, which uses file I/O operations to read in the ultrasound data. Then I have a separate fragment for each plot, and all of these fragments are then contained within a single linear layout. And then I had a few tweaks to the action bar just to add our company logo. Some of the difficulties I ran into here are lessons learned. It can be very tricky for the children of a linear layout to find out how much space they were actually assigned. So the linear layout asks them, how much space do you want? But that's not necessarily the amount of space that they got. The second thing was the graphics. There are several options for how to implement this. Since graphics are kind of closer to the hardware than you would be when you're using the standard widgets, it's very easy to make a change to your program that will cause the emulator to crash. And not just your app, but the entire emulator. So along those lines, it's very important just to make a few small changes at a time and test them. Otherwise, you can lose track of which change you made it was that caused your program not to work anymore. So at this point, I've got a working app that reads in data from a file. So what I'd like to do to extend it is to change it so that it reads that data in from over the network instead of from a file. So it can actually read from the instrument in real time. It also needs the user needs the ability to send commands to the instrument for things like setting the output power level, the number of cycles and the frequency of the pulse, and so forth. The other thing you can see here is the display can really quickly get cluttered if you have too many plots at one time. So the way people combine these plots into a single image is to use something called a waterfall display. And so I may work on implementing that next quarter. So that's my project. It was a lot of work, but also a lot of fun.